live here. We're gonna do day 3. Just trying to get everything up in front of me here real quick. Make sure that I can see chat. Somewhere I'm hearing myself. Okay, there we go. And pull up my task manager too, just because I've been having trouble with the encoding lag. Yeah, my CPU is all maxed out right now. I tried messing with one setting to see if things were working differently. I changed one of the encoding settings, but still like way up on the CPU usage. Just need a new CPU. I'm using a really old Xeon E5506. It's a very old computer. So it's got 4 cores, 2 gigahertz. It was good back in the day, but not so much anymore. But we'll go ahead and get started here. I started a little bit late today, so all right. Let me just get this off to the side here. This like that. And disable that preview because that should help reduce things down as well. And then I've just got my preview up in front of me, and I've got my chat. I got one more follower yesterday, so that's exciting. Okay, let's start on day 3. Start our timer, and let's read it. All right. The submarine has been making some odd creaking noises. So you ask it to produce a diagnostic report just in case. The diagnostic report, your puzzle input, consists of a list of binary numbers. Yay, binary. Which decodes, when decoded properly, can tell you many useful things about the conditions of the submarine. The first parameter is going to check power consumption. You need to use the binary numbers in the diagnostic report to generate 2 new binary numbers called gamma rate and epsilon rate. The power consumption can then be found by multiplying the gamma rate by the epsilon rate. Okay. Each bit in the gamma rate can be determined by finding the most common bit in the corresponding position of all the diagnostic numbers in the report. Okay. So the most common bit position, basically. For example, given the following diagnostic report, looks like the middle one is the most common. Oh no, 1. Okay, most common one is bit 1. There are 5 0 bits and 7 1 bits. They're the first bit of each number. Okay. I see. Find the most common value. So the gamma, so that's how you get the gamma. Second most common bit number of the report is 0, so the second bit of the gamma rate is 0. Okay. So basically we just want to like do a guess you could take an average of the whole thing. I should finish reading before I try and solve. Oh, he's also doing first 5 zeros. Oh, so he's saying first is this side. Not this side. That's backwards of how hardware would normally talk about bit position, but it doesn't matter. Okay, the least common bit is used. If it's equal. Maybe it always gives you an odd number of inputs, so you don't have to worry about the equal. Okay. Is this, or 22 in decimal? Okay, fine. Okay, then you multiply them together. Okay, let's get our input. Take 3 input. Let's see if we actually have an odd number. We have 1,000. What do we do if they're equal? I mean, I guess we can just see first, right? Okay, so let's write our parsing function. Parse input. So, taking a line, and I think we just want to convert the line to integer, so we can just do the same thing we did yesterday with the mapping function, and this time we're going to do int. Let's see, how do we do this? Do I have to do a lambda x comma 2, and that'll give us, read them in as binary numbers, and then we'll open day 3 input .txt. Alright, how's my encoding doing? Still not great, but hopefully it's only when I'm doing more intensive things. Hopefully it doesn't do it every time I try and run my program, which I think is what was happening yesterday, but we'll call this like binary list. Okay. So we should be able to then print this. We should be able to do it as a couple different ways, right? So let's just like print the first item, right? And then let's print it as binary? Forget how the printing format stuff works. I like the F strings, but then I don't remember how to do the format stuff. Look it up. I think it's just put a B over there. So let's just see what that looks like. Helps to spell lambda correctly. Map must have at least 2 arguments. There we go. Oh, I need one more parenthesis down here. That's why. There we go. Now we're all lined up. Seems good so far. Just slip some sleep statements in there. Okay, hey, we printed in binary and in decimal. Okay, great. So we're working. Now we need to go through it and actually view it. Actually might help to not input it as binary. Like, probably better to keep it in string form, actually. So let's just copy this real quick and just do we'll just call this string list, where we just don't map it. So it's probably easier to check what we want to check. So let's just do it brute force with a couple strings. It looks like F-strings do have some nice debug features where you can print the variable name for you. Oh, really? Throw an example for me. I'd like to know how to do that, because that is something I do really often. It makes sense that it exists. Usually I just copy and paste. Num equals with. Okay. How to put code in Python. Are you saying you do something like this? Oh, wow. Can I add another space on the other end of it, though? Oh, yeah. That's okay. I figured it out. Very cool. That is super, super useful. So, okay. So we're just going to do I in range to... How big are these numbers? They are 10. Are they 11? Oh, jeez. No, they're 12. Okay, good. They're at least... They're 3 nibbles. Yeah. And then for S in string list, we'll basically, you know, we'll just call this one count equals list and 0 count. It's obviously like probably like way better ways of doing this with, you know, fancy functional programming. There'll be some good golf solutions to this, but you know, we're just gonna do it the simple way. So we'll just take each. Let's count up each one. And that's for each index. know there's like a zeros function. Array with zeros. Let's. Oh yeah, that's right. You just do it this way. Let's do this. Get rid of our magic numbers here. Oh. No, nobody likes magic numbers. Okay. And let's use that fancy. Oh, F is on the wrong side there. Okay. There we go. And then we can just basically do that again. And we'll have gamma. And epsilon. Did I spell epsilon right? Yeah, I did. Okay. Gamma and epsilon. And basically this will be gamma of I equals, this is whichever one is more common. So, yeah, gamma is the most. So if one count is greater than 0 count. So are there odd numbers for everything? This is even, but I don't see anything equal. Yeah, I don't see anything that's like equal, so probably good. I might rewrite this afterwards. I wonder if you could do. I mean, I know gamma and epsilon are just like inverses of each other. All right, let's double check. Yeah, it's just least common. So it's just 1 minus gamma. All right. Oh yeah, I can't just multiply the lists together. I need to join them. Let's do that on a separate line here. Power consumption equals epsilon. So we're just gonna join them with nothing in between them by doing, you know, empty string.join. And then we're going to convert that to an integer, base 2. And then we're going to multiply that by gamma. Because you would typically put this on the previous line. That. Okay. Sure, you could do some bitwise operator magic to invert it. Yeah. Let's see here. Sequence item 0 expected string and integer was found. Oh, right. I don't... Hold on. Let's do a quick check of syntax here. What happens if I pass it? Yeah, it does that. Okay. So we need to map convert everything to string. Ugly, but okay. Okay. Let's give it a shot. Hey, we did it. Okay. So, yeah, a little more complicated. I definitely can, like... I should try and rewrite this a little more functionally. I think that might... But it seems like for these sorts of things, sometimes writing them in for loops helps you on the second part, so you can make changes and add variables easier when it's this two-part thing. But we'll see how part 2 goes before I judge. So part 2. Okay, next you should verify the life support rating, which can be determined by multiplying the oxygen generator rating by the CO2 scrubber rating. Both the oxygen generator rating and the CO2 scrubber are values that can be found in your diagnostic report. Finding them is the tricky part. Both values are located using a similar process that involves filtering out values until only one remains. Before searching for either rating value, start with the full list of binary values from your diagnostic report and consider just the first bit of those numbers. Then keep only the values selected by the bit criteria for the type of rating value for which you are searching. Discard numbers which do not match the bit criteria. Okay. If you only have one number left, stop. This is the rating for which you have been searching. Okay, otherwise repeat the process. Consider it for... Oh, I jumped too far. Considering the next bit to the right. The bit criteria depends on which type of rating you want to find. Rating value you want to find. To find the oxygen generator rating, determine the most common value in the bit position and keep only numbers with that bit in that position. Okay. So basically we're doing a search here where we use the most common values in each column to then find the 2020 victory. This is 2021, Alex. You can't use 2020 victory. I just noticed that my stream information is incorrect. Why won't it let me change it? Hold on here. I'm just gonna try and change my title. Hey, like, the edit stream info thing doesn't seem to work. Well, I'm gonna refresh here. Let's see. There we go. Now I got the button back. Okay. Change to day 3, and I realized there's like a technology, science and technology category that I should probably use instead of just chatting. All right. Oh yeah, and Knock Knock followed me. Very cool. Okay. So I think I understand how we're searching here. We're just doing the same thing, least common, most common, each position, and then we're using that to cut out numbers. So, yeah. So in the example above, start with all 12 numbers. First bit. Yeah, and he's doing left to right instead of right to left for bit position, which is fine because that matches string order, so it's just easier to work in strings again. Okay, do the same thing. Then multiply the numbers together. Okay. So we already have the most common values for each. Why does my multi-select not work on this computer? I can't control multi-click, huh? I can do that. Regardless. So yeah, so we need our string list here. Just make a copy of it here. And well, remaining, length of remaining is greater than 1. We will, and we also need a index. Okay. And we're just gonna make this a function so we can just pass stuff in. Yeah. So let's just do a, what they call this? Rating finder. Okay. And we'll pass in the let's see. Pass in the string list, and then we'll also pass in the either gamma or epsilon is what we want to pass in. And we called it a bit criteria. Okay, yeah, we'll pass in the bit criteria. Let's choose I. If yeah, we'll have an index and we'll have an I. Be removed from an index. That's right, you like to do delete in Python. It's the del keyword. Okay. So we'll do that. And then else we will I plus equals 1. If I is else we return back to the beginning. Whoops. Not how you write ternaries in Python. Let's see. -1. Yeah. Yeah, because we never want to hit that number. Okay. But if we get to the end of the list, then we need to increment the... Yeah. So we actually have to write it like this. And index plus equals 1. Assert index is less than number length. Let's go to caps. To upper. It's a constant. You gotta follow convention, right? Okay, let's look at our algorithm here. So we got a rating finder. We pass in the list of strings that we're gonna check. We're gonna pass in the bit criteria, which is gonna be either epsilon or gamma, which tells us whether 1 is greater or 0 is more common. Then we track, a index into this list, and then also check this logic here is a little funky. Oh, okay. Anyways, we're tracking the index into the list and then also the index into the bits. Why do I have a num? Num for... I think that's just extra. The only tricky part is if you're... What I need to do here is do I minus equals 1 every time. So this basically, we deleted something from the list, so we need to reduce our number before we go add 1, basically. Anyways, so then we continue to go around and remove things from the list based on the bit criteria until we have nothing left. And then we return that number. So O2 will equal, and the other one is the CO2. So we're gonna pass in the string list. Oh, right. Rating, binder, string list. Gamma is the more common. Epsilon is the less common. Copy our prints down here again. And then this will equal our life support rating. Okay. Okay. So we've got our rating finder. We're going to make a copy of our input. We're going to check the criteria of the first index. And if it doesn't match, then we're going to delete it. We're going to -1 to our index, our list, our I, and then we'll add 1 to it as long as we're lower than the top of the list. If we reach the top of the list, then we need to increment the index that we're looking at. Then we return whatever we have remaining. Okay, I think that does it. Okay. And so that gets us this number. Oh yeah, we're just returning these, so these don't need to be joined. I think it still worked though. Yeah, it just treated the string as a... Yeah, it was already a string, so we just needed to convert to integer. Let's simplify that real quick. So we get the same number. Yeah. All right. Oh no, it's too high. We messed up. All right. Bummer. It's the first one we've gotten wrong. All right. What is wrong here? Okay, it's just... Oh, I still have an extra parenthesis. Did it? I guess it worked, but it was just mad. Okay. So let's double check what were our assumptions here going in. Determine the most common value in the bit position. Okay, which is what we did in the first part. Right, because gamma is the most common value in each bit position, and epsilon is the least common. Okay. So we do that for both gamma and epsilon. And so we have these values for each. And then we want to find the obviously it found something. This part is tricky. Yeah, I know, it's so wordy. It's like such a wordy, dense problem. Try the example problem set. Yeah, I need to like copy it so I can actually... Yeah, I wouldn't be surprised if I was misunderstanding something here. Okay. So start with 12 numbers and consider each first bit of each number. Okay. First bit of each number. There's 7, 3, 4, 1, 5, 6, 7. And there's 7 ones and zeros. So keep only the 7 numbers with 1 in the first position. Okay. Then consider the second bit. Oh, okay. Yeah. All right. I understand it now. You can't just use gamma and epsilon. It changes. It works for the first bit, but not beyond that. All right. We'll call this you know, funk or whatever instead. Okay. So let's rewrite this a little bit. We're just gonna, I don't like to delete things. We're just gonna comment it out. Okay, let's write this more intelligently. Yeah. Yep, I got it. I got it, Alex. Don't worry. Okay. Let's do this differently. Because I would rather do 4i in range number length and 4 Need to do some counting here. Proper counting. Yeah, it's I'm using the lo-fi hip hop music for studying, Lofi Girl station on Spotify. I don't know if that ever pops up on like your YouTube or whatever, but uh, it says it's all fine for streamers to use as long as they credit. So uh, that is what I'm using. I listen to a lot of lo-fi stuff just while I work. Yeah, it's good focused music. Just not distracting. Okay. And now that I've distracted myself talking about the music, I just want to pass in the list and get either 0 or 1. So I want to map each item array. Each list, and then give me an index, and then we're going to pass in the string list, and we're going to do x.count. This is where I want to like try and use pandas again, because I just want to like split it up into columns and just get the columns, but I don't know why I don't just do something like this is really what I want. I want like double array. I've just got incomplete thoughts here. I need to comment out while I think properly here. Yeah. Great. Now let's strip it first though. For I and S. I don't know if I actually like did what I wanted though. terminal history isn't set up to be that long. Just print me the first. There we go. Zero, 1, 1, 0, 0. Yeah. Okay, great. Okay. And then per index. And then for I'm gonna fix this. Actually make this match what I had below. Hi, Userman2. Welcome to the channel. Sorry, I've been like, this one's hurting my brain more than the last couple days, so I'm not looking at chat as often. So, but welcome in. Yeah, I like completely misread the second part, so I'm like rehashing it. Yeah, no, that's why. Yeah, and it's also like you have to go through the example is what I found, because it without the example, I didn't understand what it was trying to tell me to do. You have to do like each index and then remove things and then do it again. So I needed to write a better function because I was just trying to reuse epsilon and gamma from the first part, but that just doesn't work. But yeah, welcome in. Okay, so now that we've got our list, now we're gonna go through each whoa. And actually, again, let's just use list comprehension. List comprehension is a lot more powerful than I give it credit for. So let's do per index dot count for each index. So we'll count the zeros and ones. They are strings, so let's count them like this. The only problem with this is that it makes it really hard to fit on a single line to make it easy to see. I guess I'll close the input at this point, since I don't really need that up in front of me. But we'll do more common per index. Okay. Else one. Okay, so what we've got here. I think I may have missed some very important detail or something because the least significant bit is wrong on the first part 2 reading. Yeah, no, I misread it too. So each time that you look for the most or least number in that in the set of numbers that you have, and you remove numbers, then you have to recalculate the next index. That's the part that I missed personally. That it's a very wordy problem today. It's like 4 pages of text, so it's easy to miss something. Okay. Yeah. Oh, but I just need to give it the index. That's right. That's why I was trying to pass in the index. So I really only care about one particular index. That makes it easier. Which also means I can simplify this as well. Hey, there we go. That's a little simpler. This needs to be 0 if. Yeah, so you can't just reuse gamma and epsilon from the first part. So in the first part, you calculate the least and most common for each one for the entire list. And then the next time, in part 2, you do that for the first index, and then reduce the list down. And then you do it for the second index for that that reduced list. There's also a tiebreaker condition. It's confusing. Oh yeah, what's the tiebreaker? Are equal. So keep the number of zeros. Oh, okay. So it's equal number. Okay, so it just defaults to 0 if let's see. Is it what is it? There's an equal number of zeros and ones. Keep the 1. So if 0 is greater than return 1, they're equal. Okay, so in this case, I got the default condition correct. And then if it's a tie, then we want zeros. Okay. Okay, so now let's go back to our while loop here. Thanks for pointing out the tiebreaker, Alex. That's important detail. Okay. So now I've got our list. We've got our indexes. We're going to, yeah, call our function on our remaining list. And then we're going to iterate through that list. And then we're going to, you know what we're going to do? I think this might be simpler to go backwards here. When you're removing things from a list, just start from the other end so you don't have to change your index. And then you minus equals 1. And then if I wonder if some people ran into the tiebreaker on part 1. Was there an actual tiebreaker? I was like, I thought I didn't see any actual tiebreaker rules. Yeah, I guess I just didn't run into that problem, so. This needs to be I. Yeah, that's what I thought too, user man. I would think so, but I didn't see it in the code, so, or in the description, but I just assumed that he made it not a problem in the first part. Like he just generated his puzzle input to always be that way. Okay. And then if length of remaining equals 1, or just less than or equal to 1. I guess I should have an assert there or something, but. We'll just assert false if we get out of the loop. Yeah. I mean, it'd be pretty easy to, write a constrained random function to avoid tiebreakers. Yeah, I think it's really neat how he's got the random inputs. He does a really good job with that. Unreachable. Why is that unreachable? Oh, I didn't return. There we go. Function that never exits. Okay. Oh, we've got a... Still need that via list. So we get the index for each one, then we count them and we compare them. If 0 is more common, then we return 0. If it's 1 or equal, then we return 1. And same thing on this side, but we still need to okay, so that takes care of those functions. And then rating finder. Okay, then we actually go through the lists and get the number, figure out if it's 0 or 1 for the particular index. Plus equals 0. What am I thinking there? And then we do a while we start the end of the list and we're going to go to the front, and that way if we delete, then we don't have to worry about the index shift of the list. So then we go through each thing and we delete, and then we if we ever get down to only one thing remaining, then we return. Otherwise we increment the index and go around the loop. I already have a variable I, so I need to change this to be index. And then I don't have to do this. Yeah, because I was already using index. Okay. Yeah, I am all over the place with this particular problem, but I think I've got it now. So now I think we need the same. Join logic, is that what I need? Yeah. No, we're returning this. Okay, what are we caught on? Must be a string, not an integer. Oh, I'm doing count 1 instead of count number of ones, or string ones. Why do I not have my autosave on? Index shifting is one problem that really got me bad when I first started programming. Was making an inventory saving loading plugin. Basically, I wanted to wipe the inventory and didn't have the experience to know that index shifting after I moved. Yeah, it's definitely one of the like annoying things about when you try and use a list. A set would probably be better for this problem. It'd probably be better to rewrite this using sets. Because the set functions probably are a lot more useful, and you don't really care about duplicates in the second part, so. Oh no, list index out of range. Yeah, I'm probably messing it up. Just like we're saying here. Index out of range. Let's see. Oh, ha, it's the -1. Classic. Classic off by 1. And list index out of range. That means I ran out of items. I deleted everything. What happens if you run out of everything all the way through? That probably means I messed up. Let's just put a couple prints in here to sanity check myself here. What was the other variable I wanted to look at? I. I is -1. I passed in an empty list. Oh, remaining. No, remaining is not empty. So I also care about index here. That should be 0. Yeah, index is 0. And then I gets initialized to the length of remaining, which should be a list. All right, take care. All right, this should theoretically be big. Yeah, it's a whole big thing. So why is the length of remaining? Did I modify the list when I passed it through this function? No. debugging is 0. Oh, debugging. The length remaining is 1,000. Then we come into the loop. And then we call our function. And then I bet it changed. Or no, we deleted everything, didn't we? Because our determining number is a string. That's why. Okay. Okay, now we're at least trimming things down. Our determinant number for the first one was 0. That shouldn't be the case. It should be a 1 for our first one. So I think this is wrong. First of all, let's test our function here. Yeah, it's completely off. We get the first index of every item, and then we're counting the number of zeros, and we count the number of ones. All right, I gotta mute. I've got a phone call real quick, but I'm gonna mute myself. Okay, back at it. So close. This is taking way longer than I wanted day 3 to take. Normally, I've not had this much trouble with such a simple thing, but that's how it goes sometimes. We're just gonna do some sanity checking here. Should be called S. I guess let's see if the asserts hit first, and then I assume it will, because clearly. Okay, I just misunderstand how array count works completely, don't I? Oh. Bugger. Sometimes it's really nice that strings are arrays. It could be that I've had some trouble with my encoding lag. Thank you for telling me that it's freezing up. Yeah, I can see that my CPU is all spiked right now. Hopefully it's getting better. Let me know if it still looks really bad. Yeah, I've been informed that I seem to have trouble with that. I just need a new computer. It looks like my CPU is dropping off again. Yeah, no, that'd be pretty good. I assume it also freezes everything I'm like typing and doing, so yeah, okay, good. Thank you, Tommy. Appreciate it. Yeah, now I'm back down to 80%. I tried messing with some of the encoding settings, but I haven't had any luck with that yet. I don't know if I want to decrease the overall quality more. I'm not sure if it'll be readable, but if I do that. So, gonna try some more things. I'm very new to streaming, so okay. So now let's fix these. And sure, let's just test that real quick. Still got an assertion error. Oh, great. That still didn't fix it. 497 versus 498 zeros, huh? I got one more zero than... Oh. Why would you initialize that to 1? Why would you do that? That seems like a pretty strange thing to do. Let's get rid of my debug prints now. Okay. Man. Okay. So now that looks the same as my gamma. So now I've recreated part 2 with my new functions. Let's double check my less common function just to make sure that it operates correctly. Yeah. And now we've got some... So now we actually end with the proper amount. That's good. And now we get a life support rating. And did we do it? We did it! Oh, that was way more frustrating than it should have been. But that was good. I'm definitely rusty since I kind of pair programmed Advent of Code last year, and then yeah, so it's been like 2 years since I've done these like individually by myself, doing these kind of like programming puzzles. It's definitely a lot different than work. So, yeah, that's a lot better. Let's see. What did I learn today? Today I learned that list comprehension is my friend, and I shouldn't be afraid of doing things with list comprehension. Especially because he makes these like, so it's not like I need to scale so much. So it's better to just use the list comprehension, create new variables, and just let Python handle the optimizing under the covers. So whenever you need to, just extract an index, then just write a list comprehension instead. And then I did so much like running around. I think I really shot myself in the foot by trying to like name things I and index. I think that really hurt me, but that's okay. So yeah, I got part 1 pretty quick. Yeah, I know. I shouldn't be thinking about optimizing. I mean, you want to like not always do brute force, but it would have been smart to like make this more of a function. I didn't know I needed it per index, but I don't know. Just trying to think of things I could have done better today that I could do better tomorrow. All right, I'm gonna sign off. I've actually got 5 viewers. I guess I should raid. I've never done that before, or host or something. It's probably gonna get mad at me. while I look for somebody here. It's probably gonna freeze me up again because I CPU gets mad whenever I try to load web pages. So let's go find somebody else that the people here can go watch. So let's see. I have trouble just navigating Twitch sometimes. Let's do that to find. I apologize because I am trying to figure this out. Okay, I found somebody who looks like they are early on in the... And then let's see if I can figure out the raid command. Alright, thanks everyone for watching. Oh, okay, there we go. Thanks everyone, have a good one.